We're seeing AI woven into, well, more and more of our lives, aren't we?
Hmm.
But relying on the cloud, while it's powerful, it's it isn't always ideal.
No, definitely not.
You've got the lag,
Yeah,
the latency, and the questions around privacy keep coming up.
right.
And let's be honest, the costs can really climb sometimes.
Absolutely can.
Here's where it gets really interesting, though, because we're taking a deep dive today into Google's Gemma 3N.
Ah,
It's
yes.
their latest family of open source generative AI models, and it's looking to change that cloud dependency quite a bit.
Absolutely. What sets Gemma 3N apart, I think, is its fundamental design for on-device deployment. We're talking about running sophisticated AI directly on your smartphones, tablets, laptops.
Right on the device itself.
Exactly. Imagine having, enterprise-level AI experiences without needing to constantly ping the internet.
Right. So our mission for you today is to really cut through any technical fog and understand what Gemma 3N is, why it's such a notable development, and, well, what kind of ripples it might create.
Mm.
We've got some excellent material here that provides a pretty solid overview, especially for anyone interested in the business side of AI.
Yeah, it's good stuff.
We'll be exploring its core innovations, what it could mean for various industries, and how it sort of stacks up against some of the biggest players out there.
So let's get down to it then. What is Gemma 3N in, practical terms?
Well, at its heart, it's a set of open source generative AI models from Google. That part's simple enough.
Okay.
But the key thing to grasp, I think, is that it's specifically engineered to run right there on your devices. We're talking your mobile phone, your tablet, even your laptop.
And that's a significant shift, isn't it, from how many advanced AI models traditionally operate, which is primarily, in the cloud.
Definitely.
The core advantage here is the ability to deliver genuine enterprise-grade AI capabilities directly to the user without that constant need for an internet connection.
Which immediately begs the question, why is that such a game changer? Why move away from the cloud?
Exactly. Let's revisit those initial hurdles we mentioned with cloud-based AI. Latency. That delay you feel when information has to travel miles away and back.
Yeah, can kill the experience.
It really can hinder responsiveness. Then there's data privacy. When your info is processed in the cloud, there are always, inherent questions about who has access, right?
Always.
And of course, the ongoing expenses of cloud computing, they can become substantial, particularly as your AI usage grows.
Those are definitely clear challenges.
Yeah.
But where does this on-device approach really shine? What problems does it solve in maybe a new way?
Well, consider situations where reliable internet access simply isn't a given.
Okay.
Remote areas, for instance, or specific medical applications where you need immediate results, military operations, even teams working out in the field in various industries.
Right, like field service or logistics.
Precisely. In these contexts, having AI capabilities built directly into the device isn't just a nice to have, it's often a necessity.
Okay, the picture's becoming clearer. Now, what are the really innovative aspects? What makes Gemma 3N work on a device? What's under the hood, so to speak? That makes it special. But let's keep the explanation straightforward.
Absolutely. A fundamental element is its mobile-first and offline design. It's been specifically tuned, optimized really, to run efficiently on devices powered by Android and Chrome OS.
Okay, so tailored for those platforms.
Exactly. And as we've discussed, the ability to operate completely independently of the cloud offers huge advantages for both privacy and ensuring incredibly fast, near instant response times, low latency.
Makes sense. What other tricks does Gemma 3N have up its sleeve?
What's truly fascinating, I think, is its multimodal understanding.
Multimodal. Okay.
Gemma 3N doesn't just deal with text. It can also process and make sense of information from images, audio, and even video.
Whoa.
Think of it like this. Instead of just understanding words, it can also see pictures, hear sounds, and watch videos. That allows for much, much richer interactions.
That opens up a lot of possibilities. Can you give us some concrete examples? What might that look like in action?
Sure. Imagine being able to ask your phone a question about something you've just photographed,
Uh-huh.
and the AI can understand the visual content and give you a relevant answer. Right there.
Without uploading it.
Exactly. Or think about automatically summarizing the key takeaways from a video directly on your tablet, again, without needing to upload the whole file. Enhanced voice assistants could truly understand the context of what you're saying, maybe incorporating visual cues or sounds around you.
Wow.
That's the kind of real-time, intuitive application potential we're looking at here.
That's definitely a step beyond just basic voice commands. So how does it manage all that without, you know, killing your battery instantly?
Oh, good question.
Hmm.
That's where its efficiency and performance come in. Google has made it significantly faster. The reports we're seeing indicate it's around 1.5 times faster than its predecessor, Gemma 3.4b, running on mobile chips.
1.5 times faster.
And this improvement is partly due to some clever underlying tech. One is called Matformer.
Matformer.
Yeah. Essentially, it's a more efficient type of transformer architecture. It helps the model process relationships in the data with less computation. Think of it like a more streamlined engine for the AI's brain.
Okay, a more efficient engine. Makes sense. And the other piece of tech you mentioned, something about layers.
That's per layer embedding, or PLE. Think of it as a smarter way the AI manages its memory. It caches certain information layer by layer, which helps minimize those big spikes in memory usage that can cause slowdowns or crashes on devices.
Got it. So faster and more memory friendly?
Yeah.
Now, when we talk about AI models, the term parameters always comes up. What are those, just in simple terms, and how does Gemma 3N compare there?
Right. Parameters are essentially a measure of the size and complexity of the AI's brain.
Okay.
Think of each parameter as a tiny piece of information that AI learned during training. More parameters generally mean it can handle more complex tasks.
So bigger is better.
Not necessarily, especially on a device. Gemma 3N comes in different sizes, a 5 billion parameter model and an 8 billion parameter model.
Okay, 5B and 8B.
What's particularly impressive is their relatively low RAM usage. The 5B model only needs about 2 gigabytes of RAM,
Just 2 gigs.
when the 8B model needs around 3 gigabytes. To give you some context, these are being compared to older models with maybe 2 billion or 4 billion parameters performance-wise, so it shows how lightweight and efficient Gemma 3N is for its capability.
So a lot of power packed into a relatively small memory footprint. That's key for mobile. What about languages? Is it mostly English?
Not at all. That's another strength. Gemma 3N has been trained on a huge data set covering over 140 languages.
140 plus.
Yeah, making its potential reach truly global.
That's significant. You also mentioned something called function calling.
Yeah.
Sounds a bit technical. But what does it actually let the AI do for us?
Right, function calling. It basically allows the AI to directly trigger actions on your device. Like, imagine asking it to create a calendar appointment or launch a specific app or set a reminder, and it just does it directly.
Without needing another app or service in between.
Exactly. No intermediate step. It really points towards a much more seamless, integrated AI experience on our devices in the future.
This all sounds very advanced. So who else is playing in this sandbox? How does Gemma 3N really stack up against the big names we hear about all the time? Let's dive into that competitive landscape.
That's a crucial question, yeah. The information we have positions it against some major players. You've got OpenAI's GPT-4, Meta's LaMMA3, and even Apple's MM1.
Okay, the heavy hitters.
Right. Now, each of these has its own strengths for sure, but Gemma 3N seems to be carving out a pretty unique position.
Okay, let's break down some of the key differences then. What stands out?
Well, one major distinction is deployment. GPT-4, primarily cloud, right? LaMMA3 has on-device capabilities, yes, but Gemma 3N is really architected for it, with the potential for cloud too. Apple's MM1 also designed for on-device, but, within their own ecosystem.
Tied to iOS.
Exactly. Then multimodality. Gemma 3N boasts full support across text, image, audio, and video. That's not uniformly the case with all current competitors. Some might do text and image, but full four-way multimodality is a big plus.
And what about that on-device function calling we were just talking about? How does that compare?
That's a key differentiator, I think. Gemma 3N offers it directly on the device. With GPT-4, you access it through their cloud API. Llama 3 doesn't currently offer it. Apple's MM1 has it, sure, but having it in an open source model like Gemma 3N, that offers a different level of accessibility and control for developers.
Right, and the licensing, I noticed Gemma 3N has an open license. Why is that important for people listening?
An open license is a really significant advantage for developers and businesses. It gives them much greater freedom to use, modify, and integrate Gemma 3N into their own products and services.
Fewer restrictions.
Exactly. Without the kind of restrictions you get with a proprietary license, like with GPT-4, it fosters more innovation, potentially.
And finally, how well does it actually run on, normal phones and devices?
This seems to be a core strength. It's specifically optimized for Android and Chrome OS. That potentially makes it more widely accessible than solutions tightly coupled to specific hardware, like Apple's iOS-only focus.
So if we boil it all down, what are Gemma 3N's main strategic advantages in this crowded field?
It really boils down to maybe 3 key things. First, its flexibility in deployment works across various hardware, not locked into one company's world.
Hardware neutral, kind of?
Sort of, yeah. Second, the open licensing, which encourages broader use and building on top of it. And third, its ability to process multiple kinds of data multimodal in real time, all while being efficient enough for devices with limited RAM.
This all sounds incredibly promising in theory, but let's talk real world. What are some tangible ways businesses, or even just us as users, could actually leverage Gemma 3N? Give us some concrete examples.
Okay, this is where it gets really interesting, I think, from a practical view. First, consumer devices, your phone, your smartwatch. You could have a voice assistant that's not just super fast and private because it runs locally, but can also understand images you show it, or maybe sounds happening around you. Photo enhancements could happen right there, without your pictures ever leaving your phone.
That privacy aspect is huge.
It is, and on laptops and tablets, imagine summarizing long documents instantly, or translating languages on the fly even when you're offline. Super useful for travel or just areas with bad signal.
Okay, I can definitely see the immediate benefits for personal devices. What about bigger applications, industries?
Healthcare holds significant potential. Think about remote clinics, maybe in developing regions with poor internet.
Right.
Healthcare workers could use offline tablets powered by something like Gemma 3N to get diagnostic help, or maybe perform visual checks based on photos or videos of symptoms.
Wow, like triaging based on an image.
Potentially, yeah. For businesses, think about field technicians, logistics, maintenance, that sort of thing. They could have AI assistants on their rugged devices giving real-time guidance, troubleshooting help, even offline. Meeting summaries and transcriptions could happen instantly on a company Chromebook, keeping sensitive discussion data secure and local, not floating in the cloud somewhere.
That sounds like a major boost for efficiency and just accessibility in loads of fields. What other industries might feel this?
Education is another key one. Imagine AI tutors or language learning apps that work fully offline.
Okay.
That could be huge in regions with limited internet, offering personalized learning to students who might otherwise miss out. And in retail, maybe e-commerce. We could see things like visual search built right into camera apps.
Like point your camera, shoes you lock.
Exactly. Snap a picture, and the AI finds similar items for sale running locally. Or personalized customer support via in-store tablets, again, with the AI running right there.
So it seems to unlock a lot of potential, especially where connectivity is iffy or privacy is paramount. Now, for the developers or businesses listening who are thinking, okay, I want to try this, how can they actually get their hands on Gemma 3N and start experimenting?
Google's put out several key resources. There's Google AI Studio, that's a web-based tool for testing it out, seeing how it responds to prompts.
Like a playground?
Kind of, yeah. Then there's Google AI Edge. That offers SDKs, the software development kits, and tools specifically for deploying on Android and embedded systems.
They're building apps.
Right. And importantly, the pre-trained models themselves are also available on Hugging Face.
Ah, the big AI community hub.
Exactly. So it's pretty accessible for developers to grab the models and start working with them.
So it's designed to be quite accessible for those looking to build on it. And I think I read there's an expectation of broader compatibility coming too.
Yes, Google anticipates integration with TensorFlow Lite and ONNX. These are very widely used formats for deploying machine learning models across different platforms and hardware. So that should make it even easier to use Gemma 3 in more places.
Okay, sounds like a powerful and versatile tool. But are there any catches, limitations, things we should be aware of at this stage?
Well, it's important to remember this is still technically an early preview. So stability and just how well the multimodal understanding works across all kinds of inputs, that's still being refined.
Still evolving.
Right. There are also practical things like device compatibility. For the best performance, the documentation suggests newer Android devices, ideally with 6 gigabytes of RAM or more.
So maybe not great on older phones yet.
Might be a bit slower, yeah. And finally, like with any open weight model, if you're using it commercially, it's really vital to implement strong security practices. Open doesn't mean insecure, but you need to be mindful.
Those are important points. Okay, looking ahead then, what's the bigger picture, the broader vision for this kind of on-device AI? What does the future landscape look like?
The outlook is really exciting, I think. With its efficient design, its open nature, its offline skills, Gemma 3N represents a pretty significant step towards making sophisticated AI truly accessible everywhere, not just tethered to data centers.
Bringing it out into the world.
Exactly. As our phones, wearables, all our devices get more powerful, we can probably expect to see more specialized versions of these models, fine-tuned for specific industries, maybe healthcare, law, finance.
Tailored versions.
Yeah, we'll likely see better multilingual capabilities right on the device at the edge, and perhaps most interestingly, integration into emerging tech like AR glasses, smart home devices, maybe even robotics, bringing really advanced AI to a whole new range of applications.
So, to kind of wrap up, Gemma 3N seems to be a real move towards democratizing powerful AI, making it available wherever it's needed, not just relying on distant servers. Its efficiency, its ability to understand multiple types of info, and its open access. Those seem to be its core strengths.
Precisely. It's about bringing that intelligence closer to you, the user, offering significant advantages in speed, privacy, and the ability to function effectively whether you're connected or not.
So here's the final thought for you listening. Consider how on-device AI like Gemma 3N could fundamentally reshape the way you interact with your technology, and maybe even the world around you. Think especially about those situations where you might have patchy internet or where keeping your data absolutely private is critical. Which of the applications we talked about today, the healthcare, the education, the field work, the personal device stuff, which one sparks the most interest for you, or maybe for your own field? It's definitely a space to watch very closely as this technology keeps evolving.